All right, guys, now we're going to jump into like one of the biggest chapters, and that's chapter 11, or Intro to Organic Molecules. So, organic chemistry, uh, in short, it's the chemistry of carbon, and the number of compounds that there are is just you don't know. There's so many of them. These are involved in everyday life, like you come in contact with them, your body uses them, all that stuff. Living material is carbon based, so everything that we're made out is carbon based. However, there are some other elements that are going to be included in this. We're going to have hydrogen, nitrogen, oxygen, sulfur, and phosphorus. And those other elements actually play a huge role in what's going on. Um, but we're going to be focused on carbon. Okay, number of bonds. We've got to remember this. Like, if you don't remember this, and you're going to be in deep trouble. Carbon. Carbon makes 4 bonds. That's it. Doesn't have any lone pairs. 4 single bonds, double bond, 2 single bonds, 2 double bonds, triple bond, and a single bond. That's it. Group 5, which is like nitrogen and phosphorus, they have a lone pair. They can make 3 bonds in some way, shape, or form. This applies to phosphorus as well. Sulfur can do that too. Sulfur and oxygen. We have oxygen makes a double bond or 2 single bonds, and then group 7 only makes a single bond. All right, this is got to remember this. All right. So there's a lot of different ways to classify these. All right. Organic compounds are classified by how many carbons are bound to each other. It's a big deal. And we're talking a number of carbons. Alkanes, all the carbons are singly bound to each other. There's no double bonds between carbons. Alkenes, 2 carbons have a double bond between them. It doesn't matter how many double bonds there are. If there's one carbon-carbon double bond, boom, alkene. These are the most common ones that we're going to be looking at. Alkynes, these have 2 carbons. 2 carbons have a triple bond between them. If there's only one triple bond, it still doesn't matter. That is an alkyne. So this is how we are going to be classifying them right here. So ethane, 2 carbons with a single bond. Ethene has 2 carbons and there's a double bond between them. And ethine, there's 2 carbons and a triple bond. All right. Oh, goodness gracious. Vesper. All right. Compounds have shape, and this is important to understand, and that shape is going to play a huge role in what we do, right? Compounds are not letters floating in space. They're not like little C's and O's floating around. So we're going to have to like start thinking in 3 dimensions, all right? I'm going to finish this video by talking about our slide, and then the next video I'm going to start talking about the notes. It's 3D arrangement of atoms in a molecule. Count bonds and lone pairs. That's how I'm going to approach this. This is important in enzymatic catalysts. Right? The shape of an enzyme is going to determine where it can work in the body. There's 4 geometries we're going to look at: linear, bent, tetrahedral, and trigonal planar. In the next video, I'm going to talk about these notes over here, and we're going to get into detail about these.